Hello students, welcome to JEE English by Unacademy, India's leading and largest test preparation and learning platform. Guys, we made this JEE English channel for you so that we can deliver lectures exclusively in English. And let me tell you something students, we made this channel so that we think that language should not be a barrier for a quality education. We have top-notch faculty on this channel who have previously cleared IIT JEE and other tough competitive exams, and they know what you should do to learn from the basics until the depth of every topic so that you can clear your exams without any hassle. So what are you waiting for? Click on the subscribe button and click on the bell notifications to receive timely updates. And guys, don't even forget to like this video and share the video with your friends so that you can spread the knowledge and you can support our cause. And guys, today we are going to get into current and electricity. And let me tell you something, it is a very interesting topic. Have you ever wondered how do you choose your geysers? Or like an electrical heating system? Or maybe how is your fan controlled? How do you control the speed of your fan? This sounds like a very interesting question. And we have answer for this in this lecture. If you understand this, you will be able to do it very easily. You will be able to choose your appliances very wisely. And guys, this is a very interesting and an easy topic. And in fact, it carries a lot of weightage in your exam. And you don't need to know other topics to learn current and electricity. And in fact, every topic in current and electricity is independent of each other. And if you understand one concept, you will be able to do the problems around that concept. And for hustlers, this is one of the best concepts for you, be it in physics or sciences. Alright students, let me give you a little introduction about myself. For people who know me well and good, I am Murlidharan. I completed my MS in Electrical Engineering from University of Colorado Boulder, and I am an electrical engineer who is going to, teach you and take you through this topic. And guys, I'm also an IITian. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. I have filed 22+ patent applications in India, US and Canada. And guys, not only that, I am here so that I can take you through this journey as an electrical engineer. And trust me guys, this is a very easy topic and we will understand every bits and pieces of this topic and it is going to be awesome. And let me tell you, if you attend all of my lecture series, you will get a crystal clear clarity on all the concepts in any of these topics. And guys, we have arranged something really special for you. That's our special class coming Saturday at 4 to 6 p.m. That is from 4 to 6 p.m. we are going to. That means I am also going to tell you how to score 99 percentile and above in JEE Physics. And guys, it's a special class. Don't forget to attend this class. If you're watching this video, this is one of those opportunities for you to know how to score about 99 percentile and above in physics. And guys, let me tell you something. I myself scored 99 percentile and above in physics. And in fact, physics was my best score in IIT JEE. And I know the mistakes that I did in IIT JEE and the things that I did really well in IIT JEE Physics. So I will be able to tell you how to do this so that you can excel in your IIT JEE Physics. And this is a free special class guys. So what are you thinking about? You need to, come onto this platform and enjoy this free class. And especially if you're an aspirant preparing for 2021 and 2022, you will get all the strategies that is necessary to crack JEE Physics. And guys, this is one such occasion where it is happening that we will be providing all of these strategies in a single session. And guys, do not forget to subscribe to Unacademy JEE English and also attend every lectures, because attending lectures is a very important part of excelling in your subjects and especially in physics. Physics is totally intuitive and conceptual. If you understand it, you can do wonders and magics in life. And alright guys, how do you attend this class? You can download the Unacademy app and you can install it from your Play Store or App Store, and then you can come to know about these events. And not only that, you will get special live classes from our top-notch educators across the nation. And guys, also about our, like JEE English channel on Telegram app. You can click on this link and get onto this Telegram app. And guys, you know what? We give timely updates on our class schedule. Our notes will be posted there. We have video books. You can also, come to know about all this, live updates without getting online from this one-stop solution of JEE English channel on Telegram app. It's quite an easy way to come to know about your JEE English lectures. And guys, if you're preparing for exams, we have something really interesting for you. That's our Unacademy subscription. If you're preparing for IIT JEE, you may want to choose the IIT JEE and you get live quizzes, tests, leaderboards, polls, and not only that, doubt clearing session with our top-notch educators. In fact, if you're early, you can choose the educator of your choice. And if you're in 9th class or 10th class or 11th class, you may want to go for 24-month, subscription because it's a 2-year or more long journey. And if you're a dropout or a long term, you want to go for a 12-month subscription plan, which hardly costs 2,500 per month. And if you're stuck in a lockdown and you're looking for like a 1 or 3 month program where you can, prepare for your competitive exams, you can also get that. We have over, 6,000 materials for your engineering test preparation, materials. And guys, you can use Murli Live to get a 10% instant discount on this subscription. I know this sounds awesome, and guys, do remember that test is really very important to crack exams since they're competitive exams. I know you love physics because you're attending my lecture, that means you love physics, and I also love physics, that's why I'm over here. And physics is one such subject which understands nature better than any other subjects or any other fields. And just before we get started with this current and electricity, we will have a look. If you're attending the current and electricity lecture for the third time, then you know this quote probably. This is from Thomas Alva Edison, one of the most renowned inventors in electrical engineering. He said that genius is only 1% of inspiration. The rest 99% is all about perspiration. So the geniuses that you come across are working hard. There are very, very few, not even very few people when it comes to IIT JEE who haven't worked hard. It's a competitive exams people are preparing. You need to keep, note of the time. You need to keep that, an understanding of the concepts. You need to really understand the concepts very well. You need to attend lectures every day and you need to complete everything. And yes, of course, this is 99% perspiration. But let me tell you something about this chapter or this topic. All you need is 1% perspiration and 99% understanding to crack problems in this topic. In fact, in this lecture, we'll be seeing some JEE problems which are actually a cakewalk. In fact, this subject is a cakewalk as and when you keep understanding this current and electricity. I know it sounds awesome. Let's get into the lecture. And we'll get started with a little bit of concept revision that we have done last time. Guys, I hope you remember the relationship between electric field and current density, which says that J is equal to sigma E, where sigma is the conductivity. And the conductivity is inversely proportional to resistivity. And in fact, it's a direct relation where it says that resistivity is equal to 1 by conductivity. And in fact, this equation makes a lot of sense. So let's say I have an electric field of a higher magnitude, then I would have a higher current density. And remember guys, current density is a vector quantity. It has magnitude and direction. And the direction of current density is in the direction of flow of positive charges or opposite to the flow of negative charges. And in fact, it makes sense to say that current density is equal to sigma into electric field, where sigma is the conductivity. More the ability to conduct, more the current density. And similarly, it also makes sense to say that resistivity is inversely proportional to conductivity. Resistivity is the material property, guys. It's not dependent upon dimensions. It's the material property. And resistivity is inversely or directly, you can write it as 1 by sigma. It's opposite of conductivity, where it is trying to obstruct the flow of electrons in case of conductors. And talking about the relationship between resistance and resistivity, you know that resistance is dependent upon dimensions. Guys, resistance is dependent upon dimensions. We should be clear on this point before getting into the lecture. In fact, this lecture, is independent of any other lectures, but still these are some concepts that we should revise to understand the topic that we are going to do today. And what about resistance? Resistance is the dimension dependent, like a physical quantity, or it is also the way it obstructs the, like the flow of charges, electrons or current. And how it is dependent on length and area? It is directly proportional to the length. That means more the length that these charges have to travel, that means more the resistance. And lesser the area, more congested the area, the same electron density has to travel. That means lesser means more congestion means more resistance. I hope this point is clear. So resistance is directly proportional to length and inversely proportional to area. So larger the area, lesser the resistance. Lesser the resistance for the flow of charges, because they're all flowing in three-dimensional. It's not flowing just in one direction. And how do you derive given any equation around Ohm's law? Simply make use of two relations. One is F is equal to ma, where force is the electromagnetic or the electromotive force, and the mass is nothing but mass of electrons, and it is being accelerated by the electric field. And how do we do this? Then we make use of this acceleration to find out A is equal to F by m, where E is the EQE, and then using this QE by m, you will find out the relationship between drift velocity. And what is drift velocity? Even though you are accelerating these electrons or charges in a conductor, we are talking about conductor, okay? We are specifically talking about conductor. So even though you are accelerating these, electrons, or in this case, they are bound to hit and collide by positive ions. Or rather, we'll call they get attracted to these positive ions, and they are released back again, and they are repelling among themselves as well. And due to the innate thermal energy, they are also moving in random direction. Hence, due to this phenomena, there is something like, not, like a viscosity, but an analogy would be a viscosity or a viscous solution, you can call it. Hence, the electrons would not be able to move very smoothly. They would attain a drift velocity depending on the amount of potential difference or voltage you apply to the circuit. And based on this drift velocity, we come to know that these electrons are moving with a constant drifting motion, or moving in a constant drifting motion. And how do you derive this relationship? Initially this U, that is the initial velocity, overall initial velocity, or the total net momentum of the electrons inside the conductor is 0. Since they are cancelling out each other, and also they do not have enough energy to move in a specific direction. Hence we take that to be 0, and we get V is equal to U into AT, where T is nothing but relaxation time. So this electron is accelerating, then it suddenly gets hit somewhere, gets attracted somewhere, and then it is again released. So during that time there is a relaxation time, right? From one place, from one positive ion to the other positive ion, there is a relax. Between one collision and another collision, there is a relaxation time, there is a time period. So based on this time period, it is attaining an average drift velocity. Actually, it's an average drift velocity. Really simple. This is all about Ohm's law. We have recapped the entire Ohm's law before getting into a chapter of the day. And we'll also have a look at the applications of Ohm's law. They're quite interesting, guys. Very interesting. You're using it every day, but you just, you're not realizing that we are making use of Ohm's law. And it was really that simple. And now let's get into something known as voltage and current graph. So what is this potential difference when plotted on x-axis and the current when plotted on y-axis? What does this slope tell you about? It tells you about the conductance. So how does the current vary with, variation in potential difference? If you take it the inverse way, it is about resistance. But when we are talking about potential difference on x-axis, it is all about conductance when you're talking about the slope with, the angle with x-axis. Okay guys, and in fact there was a question in IIT JEE in the previous years about this kind of concept. They asked it a little different, but it was a very similar concept. This was the concept where they interchange the axis of current and potential difference. The entire meaning of the slope changes. Okay, in fact opposite. Quite easy, really very easy. I told you it's a very interesting topic. But guys, let me ask you a question. We have been reading all about this, current and electricity, Ohms Law, what is happening to, like how these charges are flowing. Why do we have a current when there is a flowing charge? But let me ask you a question. Have you ever thought about it, like how we are making use of this, this concepts that we are learning in your real life? Pretty much many places that you're seeing every day. If you're living in a cold region or if you have been to a cold region, you should have seen these electrical heaters. These are designed, using Ohms Law only. I mean, majority of the design is based on Ohms Law. To make sure this should be the resistance to deliver this kind of, heat in the circuit. There are specific materials that are being used in it, and you'll slowly understand what kind of materials we need as and when we keep moving into this lecture. And what about your fuses in your home or fuses in your electronic devices or electrical devices? In fact, they have, they are based on Ohms Law. Pretty much every electrical equipment in your home has, like a fuse to make sure that your electrical equipment does not get spoiled due to heavy current flow. So what do you do to make sure that this fuse is the correct one? You make use of Ohms Law, but what is that specification that is required? See, a fuse should have a very high resistance. A very high resistance to the flow of current, but at the same time, it should have a low melting point, which makes sure that as the heat increases in your electrical equipment, which is the one, due to the excess current flow, the heat is increasing, all your circuits are getting heated. At that moment, I should make sure that your electrical equipment shuts down. So you select the fuse according to that. You choose the resistance of the fuse using Ohms Law and you place it in your electronic or electrical devices. So generally it's electrical devices, and you must have also seen those, the big plug kind of fuses in your home. They are also pretty much like this. This is generally what you see in, electrical equipments. If you ever, opened up an electrical equipments, you see that. Don't do that, without a supervision. Don't open up an electrical equipments, and especially make sure it is off the plug when you're, exploring any kind of electrical equipments. And guys, what about your fan? How do you control the speed of the fan? You control the resistance. You control the, current flow by controlling the resistance. More the, less the resistance, more the speed of the fan. Higher the resistance, lesser the speed of the fan. So it's really that simple. That, that little regulator that you're making use of, that is making use of Ohms Law. Really quite simple. We have been all, and you have been, and I have been all talking about, this huge electrical equipments and, fuses, heaters. What about your electronic devices like mobile, laptop or tablet that you're right now watching the video on? In fact, these, small devices are also making use of Ohms Law. In fact, when you're fabricating a PCB, you're making sure it follows Ohms Law. I mean, you're making use of Ohms Law to make sure the equivalent resistance does not, exceed the specification. And it is quite important, and you need to make sure this happens so that your devices do not get heated. And in fact, we are doing it during every electrical, circuit design, and even electronic circuit design. More apt would be to say electronic circuit design. And in fact, nowadays we don't have this, electrical resistors or the resistors that you're seeing in your lab. We have like SMTs, like surface mount, resistors. They are small. If you ever opened up a circuit board, you must have observed small, like square kind of thing, that is embedded on that board. It is nothing but either it's a resistor, capacitor, or sometimes even diode. But we have come to a generation where we have started seeing the resistors on a surface mount level, very tiny ones. Not even a centimeter sometimes. It's pretty awesome. But how do we make this happen? we need to understand the material property to make it happen. And we'll keep learning about this in our lecture. You need not worry about it. And what about the resistor design, guys? You know that the resistivity is a material property, but resistor is not a material property. You can alter the, height, width, length of a material, of a conductor to design the right kind of or the required kind of resistor that you need. Pretty interesting concept. I told you in the beginning, like Ohms Law makes use of is applied so much in our real world and makes use of concepts that can be applied in our real world. And now we understood all of these things, but what about the temperature effect on resistivity? So now we are typically talking about, conductors. So let's assume we are talking about conductors now. So what happens when you increase the temperature? The number of free electrons increases. And also the relaxation time decreases. Which means there will be more number of collisions, and with more number of electrons there will be more and more number of collisions. In a way, you must be intuitively thinking that okay, there is a lot of free electrons now as I keep eating my resistor or conductor. So why is that my resistor on eating becomes more resistive? It is because the collision time of these electrons or the free electrons have increased and the number of electrons have also increased. And the effect of the conductivity due to the increase in the number of electrons is less. Because now it is that the collision has a greater significant value in terms of mathematics or in terms of physics. These relaxation times have become so and so low that the resistivity and the resistance started increasing. Quite simple concept. In fact, you can, walk around the equations and come to know about the same thing, And what happens when you increase the temperature? The number of free electron increases due to lowering of ionization energy. And similarly, what we talked, due to more thermal energy, there will be more collisions, which means lesser relaxation time. So these are the two ways the temperature influences the resistivity or a resistance of a material. Okay, not resistance exactly. In resistance there can be like a thermal expansion, but we are not talking about it in our syllabus or as such in general, because these effects are accounted in a different way. Alright guys. So now we understood that as the temperature increases, the N should increase, the number of free electrons should increase, but at the same time the tau, the relaxation time, should decrease. This means the resistor is proportional to resistivity is proportional to temperature. Rather, I should have said both are proportional to temperature. So as the temperature increases, the obstruction to the flow of electrons and charges become more and more. Okay? And the overall N tau decreases. So it's pretty, you see at this equation and you're making sure, okay, the number of electrons have increased. Why not, the resistance should go down. But you understood the reason why it is happening. And, already the number of available free electrons are too much in a conductor. And now this increases very minute compared to the increase in the tau. The decrease in the tau. The reduction in the tau. The relaxation times have become shorter. So in a way, the overall N tau is influencing the value, not the tau alone. Not the N alone. Not just the number of free electrons have started influencing the value of resistivity or conductivity. It's the overall value of N tau. And you know that, conductivity is inversely proportional to temperature in conductors. As we keep increasing this temperature, what happens is the ability to conduct, the ability to, allow the flow of current becomes lesser and lesser, or the ability to conduct also becomes lesser. But we have been talking specifically about conductors. So what if it was semiconductors? The scenario would entirely change. Students, this concept is very, very crucial. You need to understand it very carefully. Stay attentive, stay along. And guys, you know what? Keep understanding this concept. Keep taking down the notes. Be regular on the lecture so that you'll have an awesome experience of any physics topic, and especially current and electricity. And you'll see that the next topic we are going to take it so, so amazingly conceptually and both numerically, such that you'll understand the topic in no time. And what about semiconductors? So in a conductors or a metal-like element, what is happening is as I keep increasing the temperature, the resistance is also increasing. But in semiconductor, as you keep increasing the temperature, the resistivity will go down. Why? If you have studied semiconductors, you already know the reason. If not, let me tell you. The number of hole and electron pair increases. Okay. So as the number of electrons increases, already there isn't much collision in semiconductors. It's in that state, the electrons in a semi-bound state. They are not like in a loosely bound state like metals. So once you increase this temperature, what is happening is these electrons get to the conduction band and they are able to conduct more efficiently. In short, what is happening is more number of electrons are available. Significantly more number of electrons are available to conduct. So that N that you saw over there has become larger compared to the reduction in tau. Because the collisions are not much in semiconductors and the electrons are not loosely bound, but rather, they are semi-bound. So this is quite clear, and you can also infer it from this graph. This is a graph where I plotted, resistivity versus temperature, and you can see that, this as and when this, like the temperature is increasing, the resistivity is decreasing. In fact, this graph is nothing but it's y is equal to 1 by x graph. Okay, this is nothing but y is equal to 1 by x graph. Okay, carefully notice this. This is the form of y is equal to 1 by x. Just a geometrical observation, but anyway, we know the reason why it is happening. And in fact, this is a very important concept, guys. Because what we are talking about is specifically for conductors or metals. And now what about, is there some other, material where, you'll observe no change in resistivity maybe. There is something like that. But you know what, let's once have a look at metals. So what is happening in metals? This is sort of an ideal case. Like where, or a case for copper or something, where there is, sudden increase in resistivity temperature. Initially the resistance, or the resistivity is not really, responding to the temperature, and suddenly as the temperature increases, the resistivity also increases. Okay, and the conductivity decreases. So this is quite intuitive, and this is something that we learned, and we know the reason behind this as well. So in cases of metals, the tau has a significant impact, whereas in case of semiconductor, the N has a significant impact. So the entire relation between the temperature and resistivity changes in both these cases. But what about some material that is not responding much to temperature? Yes, of course, there is something like that. And there are some special alloys like nichrome, and I think there is something like constantan or something like that, which isn't much affected by temperature. In fact, you see like a linear y is equal to mx relationship over here. But this is not totally true. This is not this true, but it is quite small. When we keep seeing this value, you'll see that it is in the order of 10 to the power minus 4, which means with a change in degree Celsius or degree Kelvin, this resistivity is going to increase by 0.001. And in cases of these special alloys, the resistivity is much unaffected by change in temperature. Okay. And there are some examples of it. I've just written in nichrome. You must go and explore more. There is constantan and other few materials like that. And is there some other material that can, conduct infinitely? Like, there isn't any resistance in the path, which means the temperature does not also matter. But there isn't something like that exactly, but there is something like that. And it is called superconductors. So what happens in superconductors is, at specific temperature, the resistivity suddenly drops to 0. Which means it can infinitely conduct the charges without any resistance, without any potential losses or energy losses. But this happens only at a temperature called critical temperature. Below this critical temperature, this phenomena is observable. And as you keep noticing, above critical temperature, it is somewhat, like as and when this, temperature is increasing, resistivity is increasing. It's pretty awesome concept. And this resistivity suddenly becomes zero at certain temperature. And now we spoke all about this. We understood the effect of temperature on resistivity. But now let's, have a look at a question, like a challenge problem. So now these concepts are clear, I guess. How do the resistance of conductor vary with increase in temperature or decrease in temperature, or similarly for semiconductors, similarly for special alloys, and similarly for superconductors. As the name says, superconductors means it is its ability to superconduct things or conduct exceptionally. Okay. So now let's say we have an IV graph where I is plotted on the x-axis of two ideal metals. It's a conceptual question, that's it. But one such question was previously given in IIT JEE. Given the IV graph of an ideal metal at two different temperatures, T1 and T2, then which of the following are true? So you have been given lines, and these lines denote something. You should be knowing it by now, that these slopes of this this T1 and T2 denote something that can talk really about the temperature. Okay, and on the x-axis current is plotted, on the y-axis voltage is plotted. So what does this mean? The slope is nothing but resistance. Okay, the slope is nothing but resistance. So guys, keep answering it along with me, keep commenting. This is very important, it's very, very important, especially if you're preparing for competitive exams or if you're strengthening your concepts and foundation. You should do it. Keep commenting the answers. I will have a look at it. Why has it gone wrong? And similarly, keep practicing it. You should do it along with me. So in this case, what should be the answer? What is happening? And what is happening? Let's understand the phenomena. So let's say the resistance at T2 is lesser than that of T1. Okay, T1 has a greater resistance because it has a greater angle and greater slope, where theta is proportional to tan theta is proportional to resistance. And in this case, if the resistance is high and it's a metal, it's an ideal metal. Okay, that means it's an ideal metal. That means the temperature T1 is greater than T2. Simply the first option. It can be determined. So D is wrong. And T1 is not equal to T2. This is also wrong. And T2 is definitely not greater than T1. We know that very well. Easy. Very easy. Quite easy. The entire concept was very easy. So now, given an IV graph of a semiconductor at two different temperatures, T1 and T2. Given an IV graph of a semiconductor at two different temperatures, T1 and T2, then which of the following are true? Same graph. So what should be the answer? It's really simple. In this case, where you are observing more resistance, the one with more slope, that is T1. But more slope, more resistance means lesser temperature. At higher temperature, it has lesser resistance. That means in this case, T2 is greater than T1. Because we are talking about semiconductors. T2 is greater than T1. I think by now this concept must be really, really clear. And we'll do a confuse me challenge problem. We'll test this concepts more. And guys, keep commenting, keep understanding the concepts. It's very important. There are three unknown materials A, B, C, which were heated to find that the conductivity of A was increasing and that of B is decreasing, while that of C was much indifferent. Guess the type of materials. So what is told over here? The conductivity of A is increasing while you are heating. That means while you are increasing the temperature. And that of B is decreasing while you are increasing the temperature. While that of C stays much indifferent while you are increasing the temperature. Okay. So probably you got the hint that C is not a metal under semiconductor. It's an alloy. Okay. Be it the conductance or the resistance, that is not being reflected. And in this confuse me challenge problem, if you have gone wrong, that means you haven't noticed the term conductivity. Okay guys, it's very important to understand and read the question. It's read and understand the question rather. Okay, first read the question and try to understand what they're asking you. Then you can jump into these options. And in fact, you can just play around options many times, even in IIT JEE, to get the final answer. So, what are the options given to us? A, B and C are metals, which is not true. And it says in this one, C is a semiconductor, which is not true. Option D says. And between A and B, we have to decide something. So, conductivity of which material increases with increase in temperature or when you supply heat? It is going to be semiconductor. So, option C is correct. And that of conductor is decreasing with increase in temperature. So, conductivity is decreasing. So, that's why it's a metal. Okay, the conductivity of metal will decrease with increase in temperature, whereas for semiconductors, they'll have more electron and hole pairs, which means the conductivity will increase. Awesome guys, I hope everyone got this one. Little tricky, if you have noticed this question, typically a confusing one, little confusing one. Given the VI graph of an ideal silicon-like materials at two different temperature, T1 and T2, then which of the following are true? So there is an ideal silicon-like material at two different temperatures, T1, T2. There are some comparison of temperatures given over here. They are asking you which one of the following are true. But what is this graph? This graph is something that we have to infer the relation between T1 and T2. So the potential is plotted on the x-axis and the current is plotted on the y-axis. That means this slope is talking about what? The slope is talking about conductance. I is equal to G into V. And this theta is higher for T1, which means at temperature T1, it has higher conductance. Which means temperature T1 for an ideal silicon-like material is greater. Because the conductance at higher temperature is higher. Really that simple. I hope everyone got this kind of question, this questions and this kind of questions. Because you must, if you have noticed, if you take up, previous year papers around, the effect of temperature on resistance, you'll notice such kind of questions. Hence, we have done all these type of questions around it. And in fact, we'll do, like a little mathematical questions, which is also something that you can get in your exam. So this question talks about given an IV graph of a metal conductor at two different temperatures, T1 and T2, then T2 is proportional to, T2 minus T1 is proportional to little mathematical, and we need to also notice the graph. So it's a typical question where they are given, temperatures at, resistances at two different temperatures. And now we need to make sure that how this T1 minus T2 is, what kind of value it is giving out. Whether it's proportional to cos 2 theta or sin 2 theta or cot 2 theta or tan theta. Little mathematical question. So see, at temperature T1 it has an angle theta with I-axis or with the current axis. Whereas at temperature T2 it makes an angle theta with the voltage axis. Which means it is making angle 90 minus theta with the current axis. Okay students, pretty simple. Now we need to find out the relationship between T2 minus T1. So what would you do? For T2 you take it as K into tan theta because resistance is proportional to temperature. And we know this tan theta is nothing but temperature. But there should be certain constant. So we'll take that T2 is equal to K into tan theta. And in this case, T2 would be k into tan 90 minus theta, and T1 would be k into tan theta. So T2 minus T1 would be k into tan 90 minus theta minus tan theta. You are sort of getting something from this, that like this is a mathematical expression which involves both sine theta and cos theta on the denominator and numerator. Probably these two are not correct, because this would only yield expression in the numerators. So what is cot theta minus tan theta? So cot theta is nothing but cos theta by sin theta, and tan theta is nothing but sin theta by cos theta. So cos theta by sin theta minus of sin theta by cos theta is equal to sin square theta minus cos square theta by sin theta cos theta. Easy, quite easy. Already you have got a hint. Multiply 2 on the denominator, then it's a sin 2 theta on the denominator, whereas on the numerator is sin square theta cos square theta minus sin square theta. Sorry guys, let me correct it. Cos theta by sin theta minus of sin theta by cos theta. And cos square gets multiplied, and sin gets multiplied, cos gets multiplied, becomes cos square, and sin gets multiplied, becomes sin square. So it would be cos square minus sin square by sin theta cos theta, and you multiply the 2 on the denominator and numerator, and you will get on the denominator it is sin 2 theta. And what is cos square theta minus sin square theta? It would be nothing but cos 2 theta, which means this is proportional to cot 2 theta. Little mathematical, I told you, but not really much mathematical if you know around trigonometry. So there is this thing about physics, and we'll be discussing this in our special classes. So there are few topics in mathematics which you need to know really well to solve JEE based problems. And there are also few topics which you need to know so that you don't miss out most of the questions in JEE Physics. Okay guys. Now R is proportional to, same thing is done over here. R is proportional to, temperature, resistance is proportional to temperature. R is nothing, actually R is equal to tan theta in this case. Actually, you know what? This should have been R is equal to tan theta, and this is T is equal to K into tan theta, and T2 minus T1 is equal to K into 90. Same thing is done over here. So you get the same answer. Finally, you get cos theta by sin theta minus sin theta by cos theta into K, and this would become cos square theta as this moves over here. I mean, you multiply this over with this, and when you multiply sin theta with sin theta, it becomes sin square theta, and that is nothing but cos 2 theta by sin 2 theta. Pretty simple. Basically, it is testing your understanding of the relationship between temperature and resistance. And we have spoke about what? Metal. If it was not metal conductor, the entire way you would have worked around the problem would have been different. Not actually much different, but it would have been little different, because T2 would not be greater than T1. That's it. So you'd get minus of something. Okay. So now what we will do is we will derive this relationship, guys. So we spoke about how this, we understood, conceptually and intuitively how this entire thing is, impacting the resistivity. Now we need to understand or derive this relationship more aptly. Let's say I increase little bit temperature, how does this resistance vary in a conductor? You can also apply the same relationship for semiconductor. You'll keep noticing that. How do we work around it? So we'll derive a standard relationship for the dependence of resistance and resistivity on temperature. Let's say I increase, the temperature a bit by delta T or dt. And the initial resistance was R0 of some conductor. Let's assume it's a conductor now. So now, what I did some experiments, and I found out that as I increase the temperature, the resistance is increasing a bit. And I also noticed that the initial resistance matters. More the initial resistance, I observed that for the same increase in temperature, the resistance is also dramatically increasing. Okay. So that being said, I can write this in this form of proportionality, equation where dr, that is change in resistance, dr is nothing but change in resistance for small dr over here. So for small dr, change in resistance is proportional to R0 dt, where R0 is the initial resistance before the heating or before the increase in temperature, and dt is that temperature change or that increase in temperature. Okay. Now we can equate this using a proportionality constant, just like how we did in how we do in Coulomb's law or gravitational equation. So we will call this proportionality constant as alpha, as thermal coefficient of resistance, and it will be denoted by alpha. Okay, so dr is equal to alpha into R0 dt, and we are calling this alpha as thermal coefficient of resistance since it is showing the dependency. This constant is showing the dependency of resistance on temperature. Easy. Now what do? We know for TR. We know for a small increase in resistance due to small increase in temperature. Now we would have to integrate it for the entire range to find out the relationship between the resistance and the temperature change. So if we integrate it from R0 to R for a dr, we would also integrate the other side for the temperature from T0 to a temperature, let's call it T. Okay. And then if you notice it, there would, what would be the integration be? R minus R0 on the LHS side, on the left hand side. So over here it would be R minus R0, and on this side what would be the integration? Alpha into R0 delta T or T minus T0. Okay. So you take this R0 on the other side, what will you get? R0 into 1 plus alpha into delta T or T minus T0. So this is the same thing that we did over here. We said R minus R0 is equal to alpha into R0 into T minus T0. You take this R0 on the other side, and then you get that R is equal to R0 into 1 plus alpha delta T or T minus T0. And this alpha is a very important parameter in determining what kind of material it is. If you know the value of alpha, you can say whether it's a metal, semiconductor, or a special alloy, or any other kind of insulator or something like that. Okay. And alpha is nothing but temperature coefficient of resistance. And what would be the unit of alpha? See, on both sides it should be ohms. R is equal to R0. So it should be ohms. This is R. So you are expecting on the other side ohms. And you are multiplying alpha into delta T or T minus T0, whose unit is Kelvin or degree Celsius. So alpha's unit would be inverse degree Celsius or inverse Kelvin. So the SI unit of alpha is inverse Kelvin. Easy? Pretty simple. It's actually a very interesting topic. Now I told you, right, using this alpha you can find out whether it's a metal, semiconductor, or some kind of special alloy. Of course we can do that. And before that, what we'll do is we will have a look at some graphs what would be given to you in exam, or let's say you do an experiment and you get this graph. How do you make out whether this is a metal? So let's say if you plot this graph, R is equal to R0 plus 1 plus alpha delta T, okay, where temperature is plotted on the x-axis. So this should be temperature plotted on the x-axis. So this should be temperature, guys. If you are taking down the notes, please do correct this. This should be temperature. Okay. If you plot the temperature on the x-axis and the resistance on the y-axis, you will notice that the intercept is nothing but R0. Y-intercept is nothing but R0. Okay. And the slope should be thermal coefficient of resistance. If you find out the slope, it would be nothing but thermal coefficient of resistance. So here is an interesting thing, guys. Actually, when you derive it or you do experimentally, you will find out this thermal coefficient of resistance is not a single, order or alpha to the power 1 quantity. In fact, there's alpha 1 plus alpha 2 t to the power 2 and etc. etc. And this alpha can also vary with temperature. But for convenience and also, the kind of, the range of temperature that we are talking, we will take alpha as always constant until and unless exclusively mentioned in your question. Sometimes it may be mentioned in a question. If you must have noticed some questions in thermodynamics. See, this is a very similar concept, isn't it? We have studied this kind of, equation in thermodynamics. And if you carefully, if they give you some equation where they say alpha is dependent upon time, some a plus bt, then you would have to include it and integrate. Okay. Or find out, because with every R naught as well, the resistance is changing. So this resistance is not just dependent upon alpha into delta t, the change in temperature into its constant, but also R naught. So you need to remember that point. Okay. And you see the slope, it's positive. So it's a metal. So I'm guessing by now you must have understood what it should be for semiconductors. For semiconductors, the resistance should decrease. Okay. The resistance should decrease. So you are expecting it to be negative. Okay. And it would be in the range of minus 0.075 and minus 0.05. Alright. So let's say I want to derive the relationship for resistivity, the dependence of resistivity on temperature. Going to be very similar, but you would have to also account the effect of thermal expansion, or in case of cooling, the size reduces, something like that. Unless and until given in a question that this, you are given, like thermal coefficient of expansion or something like that, you would not account it. In your exam, you just simply ignore it from the fact that resistance and resistivity are in fact, like proportional to each other at a first order, and the slope is nothing but L by A. Length by area, and you are assuming this length by area is not changing. Okay, awesome, easy. So I told you we can find out what kind of materials it is using alpha, and we also know that with increase in temperature, the for semiconductors the resistivity and the resistance should decrease. That means alpha should be negative. And in fact, if you notice some things carefully, you will see that for certain increase in temperature, the increase in resistivity of metals are very less compared to the increase in conductivity of semiconductors. Because they both are varying by different magnitudes. Like for temperature, the alpha, the coefficient of thermal resistance, so the thermal coefficient of resistance is going to be somewhere in the order of 10 to the power minus 3. Whereas in the cases of semiconductors, is going to be in the range of 10 to the power minus 2, even less than that, like 5 into 10 to the power minus 2. So you see those kind of effects. So for metals, alpha is greater than 0 and generally in the range of 0.0001 to 0.005 Kelvin inverse. Okay guys. And for semiconductor, you know that alpha is less than 0 and it would be in the range of minus because alpha is also less than 0. Also because with increase in temperature, the resistance is going to decrease, the conductance is going to increase for semiconductor. It's going to be in the range of minus 0.007 to minus 0.005 Kelvin minus. And for metal alloys, they should remain little indifferent. That means they are in a very large order, very small. Like it's alpha would be like 0.0010 to the power minus 4, 10 to the power minus 5 ranges. So any increase in temperature is not really affecting the resistance. But where do we make use of these kind of metal alloys? Let's say you are designing, the electrical system of your home. You must be careful about something. That your system does not get heated up. These wires do not get heated up and they consume a lot of power. So you make sure for designing any electrical instruments for a low powered one, or for like your home supply, power supply, you make sure you make use of something like metal alloys, special metal alloys that are very very low thermal coefficient of resistance. It is very important to notice that point. Like when someone is asking you what kind of material you would choose for this application, then you should be sure about it. This material resistance should not get changed much with the temperature variation. And for insulators, the alpha is 0. They are not affected by any increase in temperature, since they have very very high resistivity, generally in the range of 10 to the power 8 to 10 to the power 15 ohm meters. So this should not be Kelvin inverse, it should be ohm meters. Okay guys, that should be ohm meters. We understand it. So that is it guys. You can identify the type of metals, the type of materials using the value of thermal coefficient of resistance, or a temperature coefficient of resistance. So it's very important not only that you understand the behavior of that material and you choose the material accordingly for your application. I told you in the beginning itself, guys, in this chapter we are going to learn, how to choose your, maybe you're designing a circuit, how to choose the material, or maybe you're buying, like an equipment, like an electrical equipment or an electronic equipment. What are the factors that you need to look into before purchasing those kind of equipments? So the material matters, the quality of the material really matters. So there is a special kind of thing known as thermoresistors, a special kind of resistor. So this resistor is basically used to assess, something like temperatures. So what happens in this resistor is, this kind of thermistors are very sensitive to heat. Or let's say you supply a little heat, the alpha is so high that the resistance changes noticeably and significantly and drastically. Okay, so alpha should be very high so that you can use thermistors for heat detection, heat recognition applications. Okay, because you increase the temperature a little bit, the resistance will also increase a lot. And they are generally used to detect even a very small change in temperatures. They are generally made from oxides of metals or even semiconductors such as nickel, copper, cobalt. And talking about the alpha, or the temperature coefficient of resistance of thermistors, they can be either positive or negative as well. Okay, either way it can be. Awesome, easy, amazing application of current and electricity, and the concept of resistors and the Ohms Law. We saw about the Ohms Law's application in the beginning, but now we are exploring even better things like why this effect of temperature on resistance is important, and how does it influence my entire design of an electrical circuit, or how should I choose the electrical equipment that I need to purchase. And not only that, carries a lot of weightage in your exams, so there are many reasons to learn these kind of topics, and it's independent of other kind of topics. You need not know about maybe like basic equations are something that you need to know, but you need not know necessarily about mechanics to understand this topic. It's like pretty much topic on its own. Now let's get into the confuse me challenge problem. Guys, keep answering. This is a very very interesting question. In fact, I did discuss this but did not discuss this. So this is going to be really interesting. As the amount of heat was increased at room temperature, which of the following materials will show a decrease in resistance? Okay. Given options are A. Semiconductor, B. Ionized gases, C. Electrolyte solutions, and D. Metal alloys. So what happened was, I gave it some heat to some kind of materials and I wanted to notice a decrease in resistance. Think about this question, guys, very carefully. Take some time. You need to take some time for these kind of questions and think very, very carefully. I'm asking you this as a confuse me challenge problem is there is something really confusing in it. Or that, that you haven't noticed much. See, that semiconductor, we have discussed so much, semiconductor's resistance will decrease with increase in temperature. If you supply some heat, that means you increase the temperature. That means A is correct. But what about ionized gases and electrolyte solutions? Think about it. Why in metals there was an increase in resistance with increase in temperature? There were more collisions. It's a closely packed, like a material. Whereas ionized gases are in the form of loosely packed materials. That means there is also, there is enough or sufficient, spaces between these electrons or any ionized materials. In case of plasma, it's going to be electrons. But anyway, in these kind of ionized gases with, charges. So these charges have ample amount of space to move around. So even if you increase the temperature, they are going to move faster. That means the resistance has decreased. The same goes for electrolyte solution, loosely packed materials. And now, B is also correct. Ionized gases also show a decrease in resistance with increase in temperature or with supply of heat. And what about electrolyte solutions? Electrolyte solutions, you're also expecting something similar because they are also loosely packed materials and also the viscosity decreases. So more smoother flow of charges with increase in temperature. Pretty intuitive and conceptual if you think around the concepts and not just go by the formulas that we have been learning. Formulas are important to solve the questions quickly, but many times you'll see these formulas will fail. In fact, when we'll study about relative motion, you'll see that these formulas will fail terribly, means terribly. In fact, the questions in IIT JEE are going to be from, that domain where these formulas are going to fail. Not all of them, few of them are going to be like that. They're trying to test your conceptual ability, aptitude and everything. Guys, don't forget to attend the special classes on this coming Saturday from 4 to 6 p.m. I'm going to discuss pretty much everything that is needed to, make you strong in physics and the things that you need to do really to score that 99 percentile and above. So guys, challenge problem number 2 or the next challenge problem. And guys, this special class is a free special class on our Unacademy learning app. So don't forget about it. And the resistance of a coil is 3 ohms at 20 degrees Celsius and the alpha is given as 0.005 degrees Celsius inverse. Determine its resistance at 120 degrees Celsius. Normal problem. There is nothing, very innovative or confusing in it. It's probably these kind of problems are something that you're not going to even get in your exams. But they will, train your numerical ability. Or if you do it mentally, you become also very, very strong in terms of calculations. But I would recommend as long as you're doing lectures, it's well and good, you do that. But get in habit of, putting your pen on the paper. You have to practice it. And especially during exams, if there is a lot of confusion in your mind, try to, we are discussing concepts that are, clearing your concepts so you don't have to, worry about getting confused about concepts. But the thing is, you have to, put that pen on the paper so that these numericals are not confusing. Sometimes the values would be confusing. And in fact, you have to notice those small hints where they say, take gravity is equal to 10 meter per second square, or take this, there will be a standard value of K. In case of like the Coulomb's constant, but they would give you a specific value. You need to make use of those values because that would be easier to calculate. Okay, let's get into the question. So initially this coil was at 20 degrees Celsius and now it is at 120 degrees Celsius. That means delta T is 100 degrees Celsius and now the alpha, that is the temperature coefficient of resistance is 0.05. All you do is R is equal to R naught into 1 plus alpha into delta T. You have everything and you can find out the values. Guys, quickly, if you know the answer, comment. And train your reflexes to become faster while you are working on problems. You should be very relaxed while you're learning the concepts. You should try to, ingest and digest these concepts. But when we are talking about problems, you should be very fast. You should be fast. You should try to be very fast. That does not mean, you wrote value A, value B, value C. We will see a very systematic method to work around that. But that being said, now what is the value? Delta T is 100 degrees Celsius. Alpha is going to be 0.005 degrees Celsius inverse. That would be 100 into 0.005 is nothing but 0.5, 0.5 half. 1 plus half is nothing but 1.5 into 3 ohms. R naught initial resistance is 3. So it should be 4.5 ohms. Very simple. Awesome, guys. So it's a one-liner problem. That's what I told you. It's a one-liner problem. And you may get this in maybe like state entrances and things, but yeah, but this will train you, train your concepts. Also, you'll start, remembering this formula, but you don't have to really remember the formula. All you have to remember is, there would be a 1 in between because you're integrating it. And the changes, the temperature dependence of resistance involves both initial resistance and a thermal coefficient of resistance. Interesting problem. These kind of problems are something that you can expect in your competitive exams. The resistance of a thermometer at ice point is 5 ohm and at that of steam point is 10 ohms. The thermometer is inserted in hot water and the resistance of thermometer is found to be 8 ohms. Calculate the minimum resistance required to steam the hot water. Actually, steam point, ice point, ice point is 0 degrees Celsius. They have given the question in such a way that, sounds very interesting. So it's like you have a resistance of some thermometer at 5 ohms and that of it at steam point as 10 ohms. At ice point it is 5 ohms, okay. And the thermometer is inserted in some hot water and we found that the resistance of the thermometer is 8 ohms. In this case, you need to calculate the minimum temperature. You need to read such questions little carefully, not directly approach to a solution, to steam the hot water. So they are basically talking about this hot water being heated by certain degrees Celsius such that it can be steamed. The minimum temperature required to steam it. Now, you know R naught and the final R. All you need to find in this case is thermal coefficient of resistance. And this temperature coefficient of resistance can be found from 5 ohms and 10 ohms. So in this case, you write 10 is equal to 5 into 1 plus alpha into delta T. And from steam point to ice point, it takes 100 degrees Celsius to reach that, kind of steam to ice to steam. And that being said, that would be delta T would be 100 and 10 is equal to 5 into 1 plus alpha into 100. And 10 by 5 is nothing but 2. 2 is equal to 1 plus alpha into delta T is 100. So that should be something like, 0.1 by 100. Let's keep it 1 by 100. That's easier. So it's 2 minus 1 into alpha into delta T is 1 by, so alpha is 1 by 100. Okay. Now I have this thermometer that is at 8 ohms in this hot water. Now I need to make sure this gets more temperature so that it can be steamed. First, we need to know what is the temperature of the hot water. So what would I do is, I would assume that this is right now at 8 ohms and it needs to reach the 10 ohms to reach the steaming point and directly find out the delta T. Rather than, finding out the temperature from 5 ohms or applying, maybe R is equal to R naught into 1 plus alpha delta T. What I would choose, and I'm guessing guys you would also do that, this would save the time. So I would simply write 10 is equal to 8 into 1 plus 1 by 100 into delta T. 10 by 8, 1.25, 10 by 8, 1.25, and it's 2 by 4, 2, 5, 5, 2, yeah. 1.25 is equal to 1 plus alpha into, alpha is nothing but 1 by 100. So that would be, the 1 would go on the other side and become 0.25 on LHS. 0.25 is equal to alpha delta T. Alpha is 100. So 1 by 100, sorry. Alpha is 1 by 100. That means delta T would become 25 degrees Celsius. So the increase in temperature is 25 degrees Celsius. But you know that hot water is at 75 degrees Celsius. But we don't need that. So the answer is C. Options given are like 75 degrees, 50 degrees, 25 degrees and 6.5 degrees. So this is sort of the solution. You can also, it's the same thing. Okay, initially I found out alpha, and this alpha I wrote it in terms of 0.01 degrees Celsius inverse. There 1 by 100 was a little easier to do it. And then, so I just directly calculated the delta T between steam point and the hot water. Okay. Now it's a confuse me challenge problem, guys. That means you need to notice such problems really, really carefully. And keep replying, guys. Keep commenting. This is a very interesting problem. A semiconductor is found to have a resistance 10 ohm at 60 degrees Celsius. Okay. The semiconductor whose resistance is 10 ohms at 60 degrees Celsius. Then the possible resistance of the semiconductor at 40 degrees Celsius is. Come on, guys. Come on. Keep answering this question. Keep writing it down. Keep answering this question. And let me tell you don't have to put pen on the paper. It's quite an easy concept. It's a conceptual question, actually, more than a numerical question. There's nothing. You have, only, one known and one. I think there's only one known. So pretty much you can't find out the unknown. So what would happen? It's a semiconductor. The given options are 8 ohms, 6 ohms, 4 ohms and 12 ohms. Okay. It's a semiconductor which had 10 ohms at 60 degrees Celsius. Which had 10 ohms at 60 degrees Celsius. Now it is at 40 degrees Celsius. What should happen? Resistance should increase. The only option where resistance is increasing is 12 ohms. Easy. Rest of them is like 8 ohms less than 10 ohms, 6 ohms less than 10 ohms, 4 ohms less than 10 ohms. But you have reduced the temperature and you have reduced the conductance of the semiconductor, which means the resistance should increase. The only option that is matching is 12 ohms. That's why it's a confuse me challenge problem, guys. This is a very, very interesting question. Very interesting one. From the given graph, find the temperature coefficient of resistance and the y-intercept of the given graph. Okay. So there is a graph over here which is plotted between R by R naught, where the R by R naught is plotted on the x-axis, and delta T, change in temperature. So what would be the y-intercept and the temperature coefficient? Take a moment and think about this graph carefully. How is this graph written in form of? So R is equal to R naught into 1 plus alpha into delta T. You take the R naught on the other side. Now you take minus 1 on the other side. On the 1 plus alpha delta T, you take the plus 1 on the side, it will become minus 1. So that would be R by R naught minus 1 is equal to alpha into delta T. You want y is equal to mx plus c relation, and here it is given that this theta, the slope is 37 degrees Celsius. Okay. Now thinking carefully, R by R naught is on the x-axis. So I need the representation in terms of delta T is equal to y is equal to mx plus c. To find out the y-intercept and the slope. I have to use the slope. The slope is given to me. The slope is 37 degrees Celsius. 37 degrees, it's not Celsius, it's just 37 degrees. Okay. Now that being said, how do we do this? I take that R naught on the other side, R by R naught, and then I take 1 plus alpha delta T, that 1 on the other side, that would become R plus R naught minus 1 is equal to alpha into delta T. Now I need to make sure this y is equal to mx plus c form. I'm taking that alpha on the denominator, on denominator of LHS. Okay, that would give me 1 by alpha into R by R naught minus 1 by alpha. Okay, what would be the value of alpha when the slope is tan 37? Tan 37 is 3 by 4. Alpha should be 4 by 3. See, remember these things, guys. You have to remember the values of tan 37 degrees and tan 37, if you remember, you would also remember the value of, sin 37 and cos 37. And similarly, even for 53, actually they are like complementary angles, so you can directly write that thing. If this is 3 by 4, that would be 4 by 3. And in our case, tan 37 is nothing but 1 by alpha. That means 3 by 4 is equal to 1 by alpha. Alpha would be 4 by 3. What about the y-intercept? It's minus 1 by alpha. Okay, so it would be minus of 3 by 4. Okay, so this would be the correct answer. So alpha should be 3 by 4, y-intercept should be minus 3 by 4. This question you should have answered it by now. It was an easy question but little confusing because R by R naught was plotted on the x-axis. But do notice these kind of variations in the questions. Okay. Now this is a very interesting problem. Actually very practical and interesting problem. So there are two materials of same length and same area. Okay. There are two materials of same length and same area and they are joined in series. Series means they are joined along the, like the length or in the length, and so they are joined, like this. If this A, this B, this joined like this, not like this. So this means series. Okay. They have one common node, or we'll see that concept in the next class. But for now, just understand that if you are new to series and parallel concepts, probably most of you have already learned this. But they are joined along the length. Okay. So two materials A and B of same length and same area are joined in series as shown in the picture. So this is a picture. It shows A and B. And it seems like these guys have like different alpha and this different rho resistivity and different alpha, but the same length and the same area. Okay. And it is also found that on heating these materials, on heating the combination, the resistances do not change. Then which of the following is true? Ignore thermal expansion, stress and strain effects. There are many answers given over here. Rho A into alpha 1 minus alpha rho B into alpha 2 minus is equal to 0, or either alpha and alpha 1 is negative. So they're talking about the nature of alpha and alpha 1 and alpha 2, and how it behaves when I'm multiplying alpha and rho into alpha. See guys, now in this question, what you need to notice really careful is that it is found that on heating the resistance of the combination does not change. Here lies the hint. And guys, try this question. It's a very interesting question and do answer on the comments. Keep doing it. So, what is happening when I'm saying the resistance is not changing even if I'm heating the material? After some temperature, the combination of resistances should be equal to its initial temperature or before heating it. Okay. So I can basically write, like let's say this is R1, this has a resistance R1 and this one B has a resistance R2. So I can basically write R1 plus R2 is equal to R1 into 1 plus alpha delta T or some R0 into alpha delta T plus of some R A B naught into 1 plus alpha of delta T. Okay. So assessing the final resistance, you found that the initial resistance is RA plus RB. Okay. And then you are saying that final resistance is going to be RA into 1 plus alpha delta T, and for B it is going to be RB into 1 plus alpha delta T. Even if you add, because these are final resistances, right? Ra into 1 plus alpha delta T, assuming initial resistance was Ra, and similarly for Rb it would be Rb into 1 plus alpha delta T for initial resistance being Rb. So in that case, you would say that I would add this both resistances, that is that, after thermal, after the thermal effect, if I'm adding these both resistances, there should be no expansion. That means, there should be no change in resistance. That means they are equal to the initial resistance, that is Ra plus Rb. In case of series, you are going to say the combination of resistance is nothing but the sum of resistances connected in series. But you can, in this case, that is just material connected in series. What you can do is you can basically work around, rho into L by A formula to get this answer as well. But anyway, we'll see how to do this. Since I, you work on one other thing that you must have got by now is alpha 1 and alpha 2 are either one of them is negative. That is when it is possible. See, if you heat two metals in combination, it should expand. And if you heat, a metal or let's say a material that has negative alpha and the other one that has positive alpha, it should, the resistance should increase. I'm sorry guys, the resistance should increase. Let's say if you have two, materials for which one the resistance is increasing and for the other one the resistance is decreasing, means the one where the resistance is decreasing should have negative alpha. The one where resistance is increasing should have positive alpha. That is when this is possible, isn't it? Else it is not possible. If both of them have positive alpha, it is not possible. The resistance will increase. If both have negative alpha, that means it is not possible because the resistance will decrease with increase in temperature. But we'll work on this problem. So I'm calling, this is something that I told you. Just for now, if you're new to this topic, just remember that Ra series combination net resistance is equal to Ra plus Rb. And I am saying that the initial combination resistance should be equal to the final combination resistance. Now the initial combination resistance is nothing but Ra plus Rb or Rai plus Rb. And how do you find the final? After some delta T increase, this would be the final resistance of Rai into 1 plus alpha delta T, and for Rb it would be Rbi into 1 plus, this is not 2, okay, alpha 2 delta T, okay, this is 2. 1 plus alpha 2 into delta T, okay. So now I'm ignoring stress, strain, thermal expansion and strain effects. That means I can write the expression in the form of rho as well. Okay, that means rho Ai plus rho Bi is equal to rho Ai into 1 plus alpha 1 into delta T and rho Bi into 1 plus alpha 2 into delta T. Guys, did you understand this? How did I write it? I'm assuming there was a delta T increase in temperature. So that means the final resistance would be alpha Ai, where rho Ai or Rai is the initial resistance or resistivity multiplied into 1 plus alpha delta T, which gives me the final resistance after the delta T increase in temperature. And the same goes for rho Bi or Rbi, resistance Bi or resistivity Bi. So that being said, you can work around this equation. You see this rho and rho will get cancelled because 1 plus rho, right? So 1 plus rho Ai, which means this one and this Ai will get cancelled, rho Ai, and this rho Bi and this one would get cancelled. So what would be the equation? Rho Ai into alpha Ai plus of rho Bi into alpha 2. This should have been like alpha 1. Okay, alpha 1. Rho Ai into alpha 1 plus rho Bi into alpha 2 is equal to 0, which is nothing but rho A into alpha 1 plus of rho B into alpha 2 is equal to 0. Okay, easy, quite easy. Little bit tricky that you have to understand that alphas have opposite value in this case. Opposite signs in this case. One should be positive, the other one should be negative. So that being said, we have to choose one among those options. You can also do it the other way around, just by looking at the options. So given options are alpha A into rho A, I'm really sorry, rho A into alpha 1 minus of rho B into alpha 2 is equal to 0. And they're saying either alpha 1 and alpha 2 is negative. Okay. Now, if you add this negative sign and this equation holds true, that means what we have discussed now is wrong. Okay, if this relation holds true and there is a negative sign, that makes it 0, which means either of them had to be positive. I mean, both of them had to be either positive or negative, alpha 1 and alpha 2. We know rho A and rho B are not negative. Okay, material probability, resistivity, generally, I mean, there is something known as, okay, that is not in our syllabus and not in a topic, but this is not, like this is something that you have to understand, that rho A and rho B are not going to be negative, alpha 1 and alpha 2 can be negative. And when I'm saying rho A into alpha 1 minus rho B into alpha 2 is equal to 0, that also means both of them had to be either positive or negative. And here it is given either of them is, negative. So which itself is not true. Now, rho A alpha 1 plus rho B alpha 2 is equal to 0. Either A1 and A2 is negative. We already solved this. So we know this is the answer. So, but anyway, we'll go through the options. So rho A into alpha 1 plus rho B into alpha 2 is equal to 0. Both alpha 1 and alpha 2 are positive. This statement is not true. And this cannot be also true. Okay. And again, so you need to anyway work around the equation. So this one says that alpha A, rho A, alpha 1 minus rho B, alpha 2 is equal to 0, where both alpha 1 and alpha 2 are positive. But anyway, that, if you intuitively think about it, you are adding the final resistances after delta T increase in temperature and the initial resistances and equating them. In that case, probably you're not going to get a negative sign. Okay, it's actually a one-liner problem if you carefully think about it. It's a little conceptual problem, but a one-liner problem. Alright, students, we'll do another interesting problem. I don't think, much of your questions or any, like your competitive exam questions or concepts should go beyond this on effect of resistance, on effect of temperature on resistances. Do have a look if there is something like, like a little complicated topic on effect of temperature on resistances. Do comment and do let me know about the topic. We'll work on it. And there are two materials, A and B, of resistance R1 and R2. Okay. And they also have alpha 1 and alpha 2 as their temperature coefficient of resistance. So A has temperature coefficient of resistance as alpha 1 and its resistance as R1, and B has temperature coefficient of resistance as alpha 2 and resistance as R2. And both are joined in series. Find the effective coefficient of thermal resistance of the net resistance. We just spoke. One thing you can do is like directly do the R1 plus R2 to find out the net resistance. But what are they asking us? Effective coefficient or the net coefficient of thermal resistance of the net resistance or the series resistance combination. Okay. So what would you do? You would simply add R1 and R2 and try to bring it in the form of 1 plus alpha into delta T. And when you try to bring it in the form of 1 plus alpha into delta T, you will find out that, if you do some R is equal to some R, initial. In this case, R initial should be R1 plus R2. Okay. Should yield me a result in the form of R1 plus R2 into 1 plus alpha into some delta T, where the alpha is something that we have to find out in this case, effective coefficient of thermal resistance. Should be like effective temperature coefficient of thermal resistance, anyway, of the net resistance. So we have for net resistance, we are going to add both. And how do we get this? So you add R1 into 1 plus alpha 1 into delta T plus of R2 into 1 plus alpha 2 into delta T. So when you add this both, you can take this R1 plus R2, a separate thing. Because we know in series combination, the net resistance is R1 plus R2. So you take R1 plus R2 as, one of the terms, and you basically take this term out as common. Or even you can write it like this. You can write it as, you can write the second term, the third and the fourth term, alpha 1 into delta t into r1, which you would get it from here. Okay. And similarly, you would get, alpha 2 into delta t into r2 from here. Okay. Now you take this r1 plus r2 as directly common, or you can write the equation in this form. Okay, you can write it, you can directly take from the third and the fourth term r1 plus r2 as common, and then you would get that r1 into alpha 1 plus r2 into alpha 2 by r1 r2 as a separate term. Now you pretty much understood this term, which I am highlighting in green or rounding in green highlighter, is the net temperature coefficient of resistance. So you take R1 into R2 plus common and you would get the same thing, R1 plus R2 into 1 plus R1 alpha 1 plus of R2 alpha 2 divided by R1 plus R2. And this you would call it as net, this is net series resistance. You know that R1 plus R2 is net series resistance. We, spoke about it a lot of times. That would become R series. And this term is nothing but alpha net, or the effective temperature coefficient of resistance. So the effective temperature coefficient of resistance is R1 alpha 1 plus R2 alpha 2 by R1 plus R2. Okay. So that was easy. This is the answer. And in fact, let me tell you a trick. You can't add alpha 1 and alpha 2 and divide it directly by 2, series combination resistance. So this is a false one. And neither this would hold true, because there is, no opportunity to take an under root. So these two are also false then. So the answer should be B, that way as well. But don't work around these kind of, easy tricks, because easy tricks are sometimes a little bit slower than, working the longer way or the right way of doing it. And also in these kind of situations, when you're practicing, you don't want to do that. You want to understand how to solve the problem, you want to understand the concepts. So each and every problem that we are solving also has a concept in it, a concept embedded in it. You are seeing the resistance dependence of the effective coefficient, thermal coefficient of resistance, when you're putting two conductors or two resistors in series combination. This is a very interesting concept, guys. And guys, stay tuned. The next topic is going to be a very, very important topic, where we are going to discuss about the one in electricity and magnetism that has the most weightage in this all of this. Electricity and current and electricity topic. So stay tuned. If you like this video, and share this video, guys, and guys, keep smiling, value your love, ignore gossips at this time or any time, and work hard to achieve that success, guys. It's about 99% perspiration. So you need to work hard. Let's say this topic is easy. This is something that, you listen to the concepts, maybe coming to JEE English or anywhere else, and then you apply this on your practice problems, you would be able to do it. But the most important thing is you need to practice. You need to keep on giving the test, or you need to keep on practicing. And guys, don't just keep the knowledge you acquired it, share the knowledge will grow, and you will also become brilliant, because you will be brainstorming with your friends and you'll understand what is going wrong. I know you guys are already brilliant. Why not become more smarter? So share this channel. Do not forget to share this channel. And guys, one more important thing. We have a free special class on how to score 99 percentile and above in JEE English. And physics is one of those subjects where it can be done very easily, given that you understand the nitty-gritty about this JEE Physics. Because JEE Physics has a little bit of tricks, especially advanced JEE Physics has a little bit of tricks involved in it. If you see the questions, or even JEE Mains, they have a little bit of, nitty-gritty in them. Like, there are a few things, like few strategies that you need to work around. One is like attending classes, one is like having a schedule. So we'll discuss about it in detail in the coming free special live class this Saturday from 4 to 6 p.m. Guys, don't forget to subscribe to Unacademy JEE English. And guys, if you are looking for a learning app where you can get free special live classes from top-notch educators, then you may want to install Unacademy learning app. Events like these are happening every now and then, and you also have free special classes. In fact, I'll be taking few special classes on some concept revision or some concepts in the coming time on Unacademy Learning app. And if you're looking for some test series or looking for some live quizzes for your JEE preparation, you may want to get this Unacademy subscription. You want to purchase this Unacademy subscription. And guys, you know what? The subscription hardly costs 1,500 for a 24-month package. And if you're long term or like a dropout, it hardly costs 2,500 per month. And you may want to apply the Murli Live coupon code to get a 10% instant discount on your purchase. And guys, that's it. Thank you so much. Awesome one, and stay safe. Bye bye guys. Take care.